All right, so we're starting the stream. Let me just kind of confirm an item or two. And so, yeah, I felt like that was a good question. We're going to go ahead and do a quick recap on the main structure of my course. Yeah. Let me see. Let's go here. Done. Student in. Okay. Let's see. And let me go ahead and start sharing my screen as well. That's just easier. Microphone on, start the broadcast. G. Okay. Let's see. As far as announcements, so let's paste it here. Cool. 2 p.m. No, it's not. Okay. Let's see. Let me save this attendance. So a student just asked a question. He said that he submitted an assignment and he said there was a 10% late penalty. That is correct. So all the assignments have due dates associated with them. We are at the end of week 3, right? So one thing is that we have exam 1 that's going to become available next Wednesday at the start of class, and it'll be available for 7 days. For all of our assignments, they all have due dates associated with them. Leading up to the due date, you can earn up to 100%, and then after the due date, you can continue to work on it past the due date, but there is a 10% late penalty. That's with everything. So with all the assignments, we get unlimited attempts. You can work on all assignments past the due date with only a 10% late penalty. There is a hard deadline towards the end of the semester, which is like May 1st. It's a Sunday night at midnight going into Monday morning. That's going into the week of finals. When we go into the week of finals, the idea is that for those like 5 days during the week of finals, you'll have access to our final exam and only the final. Everything else is going to be locked out. So that way, when you're taking your final, that'll be the last thing. And then once you're done with your final, that's it. So it's like no lingering items past that point, right? Another piece of information is that with my exams, so hopefully you've been making your way through the homework and the quizzes. I know that several of my classes have group meetings. I think that's a good idea. I encourage it. I think just as long, I don't mind you guys working together, just get the things done. So I do encourage you all to work together, sit down with the tutors. You've already paid the tutors. The tutoring service is a part of the tuition. So when you don't use it, you're just pretty much just throwing your money away, right? So since you've paid for the tutors, just take advantage of that service and use it. You can sit down with the lecturers and go through lectures with them, the assignments. It's totally okay. Just sit down. I just want you to kind of be working on this stuff. I can't think of anything else. Okay. And so, yeah, if you have questions about anything or if anything is not clear, just feel free to unmute yourself and we'll stop and talk about it. And again, the original intent of class time, I did kind of want class time to be a Q&A, but to get students to kind of speak up is a lot of times like pulling teeth. So what I've been doing instead is just I go through as many homework questions as I can, right? But if you want to work on something else, we can. Okay. So with that, we're going to pick up where we left off. So exam 1 is basically going to be of the first 3 sections. I think we did 1, 7, 2, 5, and 3, 1, right? And you'll notice that with my exams, they're going to be a little bit different than what's been assigned. So the homework, you get unlimited attempts, and then you have the question aid. Hopefully you've made it through those quizzes, right? So the quizzes, you'll notice that it's maybe like 5 questions, but there's no aid and you can't see your score until the end. So you take it, you get a score, right? And if you don't like the score, you can do it again. The exam is similar to the quiz, but I will tell you that basically I did like a pool where, like, say you take the exam, you get a score. When you go to take it again, it'll be different questions but the same content. All right, so it'll still be stuff pertaining to these topics, that I mentioned earlier, but it's going to be a completely different exam, and it's going to change every time you take it. But again, the content material will be the same. It'll be the same content. So because I do that puts me at ease with the structure of our class, and that makes me okay with like allowing you all to get unlimited attempts and only a 10% late penalty for the entire semester, right? And the bulk of your grade comes from these exams, right? The homework and quizzes, the homework, even though that's a lot of work, that's really just there to kind of for you to practice and so you can get ready for your exam. And then when you go to take the exam, it's pretty much based on the homework, right? It just looks a little bit different, but it's the same thing as the homework, just with different numbers, right? So with that, let's take some time to continue going through section 3.1, exponential functions. So this is question 12. This comes from section 3.1. This is question 43 from the back of the text, right? So if you had a hard copy book, I usually try to include the question IDs whenever possible, so that way you can like research and you know where to find it in the text. So this one asks us to use the formula for simple interest and the given values to find the interest, right? So section 3.1, we have exponential functions, and we introduce interest, and the first type of interest that we introduce is called simple interest. That's the lowest form of interest that we have. The formula for simple interest is I equals PRT. The principal times the rate times the time, right? So I'm just going to kind of take the notes here and like kind of work back and forth here, since this one's kind of simple. So our principal is at 1747. So I'm going to put 1747, then I'm going to say times. The rate is 7%, but the rate, we always have to express it as a decimal. So 7% as a decimal is 0.07. I'm going to say times again. And then the T, this is in months. Now, usually when we're using these compound interest formulas, usually the time is in years. So we need to convert 5 months to years. And in this case, we do that by saying basically 5 divided by 12, right? So it's going to be 5/12 of a year. So I'm just going to do it like this for now, 5 over 12, okay? So then we just need to crunch that number. So to crunch that number, let me see if I can get it to work. Is it not there anymore? It may be. Let's bring this back up. Agree, choose the file right here. Okay. Reload and refresh. All right. So we're going to go ahead and crunch that number, right? Let's see. So we said 1747 times 0.07 times. I'm just going to do in parentheses 5 divided by 12. It says round to 2 decimal places. Okay, enter. 5095. So now I'm going to take all of this that we typed, if I can get it to work. It has been a little bit temperamental. I got to do all this extra stuff, but that's okay. I think I've worked out most of the kinks. 50, I think we said 5095. 5095. Okay. So the interest earned after 5 months is earned about $51. Okay, let's go to the next question. If 12,000, let me suppress my calculator. If $12,000 is deposited into a bank account paying 6% compounded quarterly, what amount will be in the account after 7 years? How much interest? Okay, so after 7 years, right? So this is compound interest formula. I'm going to take notes here because I feel like I can. The future amount is going to be equal to the principal times 1 plus R over N to the power of N times T. That's the compound interest formula, right? That's what we're going to use. So I'm just kind of taking notes here because I feel like that way we can I feel like I can do it and we'll be okay. So then what we're going to do is we're going to go and just basically plug in the different components. So we do want the future amount, so we're solving for A. The principal, which is the P, we started with 12,000. So I'm going to go ahead and plug in 12,000 there, right? We're keeping the 1. It said compounded quarterly, okay? So the 6% is our rate. So again, the percent, we have to put it in as a decimal. So we're going to put 0.06. If it says compounded quarterly, that means we're applying the interest 4 times in a year. So our N is 4. Again, right here, our N is 4. And then it says for 7 years. Again, time has to be in years. So on my calculator, what you see now on the screen, that's what I'm going to type in my calculator, okay? So we're going to pull up our trusty dusty rusty, okay? We got 12, 1, 2, 3, boom, parentheses. 1 plus 0.06 divided by 4, okay? I'm going to close off the set of parentheses. Hit my caret for the exponent, and I'm going to put this exponent in parentheses. 4 compoundings per year times 7 years, okay? those are all the pieces put there. Everything was good. I'm going to hit enter. And then I know I have to like hit this X. And now I'm going to basically replace all these notes with that number. And usually it's 2 decimal places. Oh, to the nearest cent. Yeah, that's the same thing, right? 18206. 18206.67, right? That 36 tells us to round the next digit up, so we round it to 67. Okay, going once, going twice. God is good, all right? Again, just stop me if I'm like moving too fast, talking too fast. If anything is not clear, we can go back. I'm just moving at my natural rhythm. Again, this is being live streamed to my YouTube, so feel free to, you can always pull it up later. Let me do one more question before I check attendance again, see if anybody's in the waiting room. Okay. Oh, how much interest will be earned during the 7 years, all right? So if they started with 12,000 and they finished with the 18,206.67, so then what is it? 8 minus 2 is going to be 6,000. So 6206. So right here, we're just subtracting 62. This 6206.67, 6206.67. So I just basically what I did was the answer that we got minus 12,000 and this one, and it was really just 18 minus 12, and then the rest of that stuff. All right. Okay. Let's go with this. All right. Let me hop back over to Zoom really quickly and just kind of check on the status there. It doesn't look like we have anyone in the waiting room, and I think the chat looks clear as well. Okay. Okay. On to the next one. Let me make sure I save the attendance as well. Hey, thank you. The sound is about to make me throw up. My dog is over there like cleaning stuff, and it's just, that sound is just like, ugh. It always makes me want to throw up. Okay. Find the amount that results from the given investment. We have $70 invested at 12% compounded continuously, right? So whenever you see continuous compoundings, that's PERT. A equals P e to the power of RT, PERT, right? You see the PERT? So find the amounts that we're solving for A. The P is our principal, so we're starting with $70. So we're just going to change P to 70. Okay. E is just a function in the calculator, so that just persists or that stays. If it's 12%, remember percent we have to write as a decimal, so we're going to put 0.12, and then the years for 2 years. So this is what we type into our calculator. Okay. So then we're going to have 70 times E to the power of 0.12 times 2. Okay. We get this result. It says round to the nearest cent, which is going to be 99, so 88.99. So I'm going to get rid of all of this and change it to 88.99. Okay, on to the next one. Find the principal that will generate the given future value with this information compounded annually. All right. Okay. So for this one, I'm going to take some notes, and we're going to hop over to notability. Okay, and this is the right one. So let me suppress it for like copy this. And I usually like to get the header so that way if we ever reference this, we know where we're getting it from. It's not a mystery, and we want to copy the original question. We're going to take this, drop it in the notability. All right, that looks good. And then full screen. Okay. All right. Let's go like this. So we're asked to find the principal. It says compounded annually, so we're applying the interest per year. So we're going to use the compound interest formula. I'm going to use this one. So the future amount is going to be equal to P times 1 plus R over N to the power of NT. Okay. Hopefully you're taking notes. You have a formula sheet. It is a good idea you want to take good notes. Like the better you are at taking notes and the more organized you are, the less likely you are to get fooled by the same question, right? So I know I'm not writing everything out, but you definitely want to have a copy of like any work that you're doing. Like you want to have a copy of the notes that I do in my lectures, completed, but you can actually just pull it from Blackboard. But I think what would be better is if you took the blank copy that I make available and then you fill it in. First, you try to fill it in yourself without assistance, and then watch the lectures, and then kind of follow along with me, take notes, write stuff down. And then once you've done that, then when you're going through the homework, you just want to have a copy of it. And like whenever you want to be neat and organized, you want to have a copy of the original question. You want to have a copy of your work with the correct final answer. So that way, obviously if we're doing a remote exam and I haven't said, obviously I can't stop you from like using notes and things. If you had your notes ready to go, you could use them. But if you don't have notes, I found that like if you don't create your own notes, even if you get a copy of notes, it don't really be serving you that well. I mean, you kind of can do it, but it don't really. It's better when you make it yourself because then you have an intimate relationship with the information. And like there's still more to the story, but for right now, that is more than enough, right? Okay. Find the principal. So we're solving for P. We're going to have a future value of 10,000. All right. So I'm going to bring this out. We have a future value of 10,000. We're solving for P. The rate is 7%. So that's going to be 0.07. Compounded annually. So that's going to be a 1 for 11 years. So to the power of 1 times 11. Okay. So then if we solve for P, so notice this thing over here to the right is just some number. Once we crunch all that, we just have basically, we have some number times P. We just got something times P, right? So if we want to solve for P, we're going to divide both sides by whatever this something is, all right? So then long story short, P is going to be equal to this guy, copy and paste. Let's see, divided by, under 10,000. We divided both sides by that. Let me, this line is just irking me. So. Okay, that's good enough. Okay, all right. So then whatever that number is, that'll tell us what P is. So what I'm going to do, hop back. Let's go back over here. And then can I like drag to back what I want? Okay. Guess I gotta do it from here. Oh, I didn't know that was gonna happen. Okay. So we're gonna work this. On top we have 10, 1, 2, 3, 1 plus 0.07, power of 1. That's not 11. Cool. I just learned something new. I didn't know I could do that. Like keep this hovering window and switch between apps. I didn't know I could do that. Okay. And this is all done on the iPad. This is like after the latest update or whatever. This is just interesting to me. Like I have more fun just using the mechanics. Talking about the math is fun too. Don't get it twisted. I know it's. Go ahead.
There's 2 students that texted us in the group me that are waiting.
Okay, yeah, let me get them. I'll get them.
Thank you.
Yeah, thanks. Let's see. Let's hop here. Cool, like this. Yeah. So yeah, that's exactly what I intended you to do because, like, anyway, that is totally fine. Because I get distracted. I get in my rhythm. I suppressed the sounds though because that was distracting me. I was like, okay, people coming and going. That was like breaking my rhythm. So yeah, I don't mind if they're waiting. They can get your attention. Say, hey, can you let us in? You're like, yeah, I got you. There's 1, 2, Oh, he's on two different devices. It's fine. And then okay, I think I got everybody. Cool beans. Thanks for that. Yeah. All right. Let me see. Where did we leave off? We'll get back. Yeah. Cool. That's exactly what I want. Okay. Because that happens with this thing. All right. They kind of keep moving and grooving. So I didn't know you guys were there for so long. So it's 93. So 47, 50, 93. 40 is the next one. No. Well, we don't have that many remaining. We only have about 6 questions left, but let's keep going. Find the principal that would generate this future value at this rate compounded daily for 11 years, right? So with the example that I just did, the reason I kept those ones because I worked some similar questions earlier, and there was the immediate next question was the same thing, just with different numbers, right? So that's what's happening here. This is actually the exact same as the previous, so I'm just going to use what I had in the calculator from before and just make the changes. So the future amount was 15,000, so that 10,000 changes to 15,000. I didn't know I could do that. Man, I keep learning new things. The rate in this case is 8%. It says compounded daily, so I'm going to insert second insert. And that instead of being compounded annually, daily means what? 365. 365. Okay. And then this is going to be 365, and I think we're still working with 11 years. So insert 365. Okay, and 11 years. All right, let's go with it. So we started, oh, the principal. So if we start with 62, 22, 34. 62, 22, 34. Okay. Cool. Next question. All right, this is good. I'm assuming you guys can hear me okay as well. This is the first time I'm like doing the recording without my headphone because I feel like it might work, and so I'm just trying it out. Okay, let's look at this one, right? Can we change it again? Okay. It says sketch the graph of the function and check the graph of the graphing calculator. Before doing so, describe how the graph of the function can be obtained from the graph of the basic exponential function, right? So this is a discussion on transformations. Now, this one was a little interesting because we had 2 transformations on the inside of our basic function. So the way we did it earlier, we started with the graph here. I think I can do it down here. So the base function is e to the, okay, let's zoom out. That'll fix a lot of this. Close this out. Yeah. All right. So the base function is e to the power of x, right? Then we want to go, thank you. Oh, I know. All right. Let's see. So what we ended up doing first, so we started with the base function e to the x. Then we added the 5, right? So if we add 5 inside the base function, that should move it left. Left 5 units, right? Oh, come on. 5 units. And then we introduce the negative. So, you know, you can take that sign as is, right? So we went left 5. We started with the exponential, we go left 5, and then we flip horizontally over the y-axis, right? Let's check that one. Okay, and then in a graphical sense, So again, the upper right is parabola. That's the U-shaped curve. That's not what we're doing here. The middle left is a cubic function. We can skip that one. It's not the middle right either. That's a log function. We're doing exponential, which is the bottom left, right? I'm just going to click. This menu pops up. First, we said we went horizontal shift. Let me see. Let me see something. So if I put in a -5, now type it into this, it does kind of get a little bit trippy. Let me see if I can get that to register first. Did that go through? Can I edit? Yeah, there it is. That's what I wanted. So we moved it left 5 first, then we flip across the y-axis. And I think that's the proper graph. I think so. We're going to submit it and see what happens. Okay. So we had to kind of force it to take that left translation first before we did the flip. And the order there is important. Like if you do it in a different order, you might get a different graph. Let me think about it. Yeah, because if you flip it first and then move it left, it'll be in a different orientation. Another thing that you can do when you get your final graph, just check a few points and make sure that they match your original function. Like, okay, like looking at this, when x is like 5, you should get a 1. You just want to confirm a few points. Just confirm a few points, right? Okay, let's go to the next question. Okay, hopefully everyone is enjoying their Friday, and we only have like a little bit more than 10 minutes remaining, like that I want to keep it. I might not even keep it that long, maybe, we'll see. Use transformations of the graph of this to graph this function. So it's kind of a similar question. So we're just doing transformation, and this one only has one transformation, right? So we're gonna go here. I'm just clicking on the graph someplace random. Oh, first we need to choose the correct graphing tool, which is upper right, exponential. Then we click someplace random. And so that's the generic exponential graph, but then we have that -5 on the outside of our base function. So subtracting 5 on the outside of our base function is going to move our graph. Hopefully you are thinking down, right? We want to go down 5 units, okay? So I try to pause so that you can like come to some conclusion on your own. Come on, there we go. Hit save. That was the only transformation. We just went down by 5. I'm gonna check, okay? And the same way I'm kind of going through this homework here, like if you're stuck on a homework question, if you make use, like if you see where it says get more help, and if you click on the ask my instructor, it'll send me a screenshot of your very question. You can challenge questions, like you say, hey, I think I got this right. We can talk about it. If you need help with it, I can make you a dedicated YouTube video. I mean, and the only trouble is like, you can use that. I'm just not good about checking my emails. I'll be like busy when I'm not with you guys. But at least it'll be on file. And if I don't respond in the email, just ask me next time we meet each other. Right? Let me see. What equation represents the asymptote of this, right? So the asymptote, so exponentials have a horizontal asymptote. Normally that horizontal asymptote is the x-axis, which is y equals 0. But because this one, we translated it down 5 steps. So now it's going to be y equals -5. We can get this menu to open up. Y equals -5. Okay. That's the next. What's the domain? So for exponential functions, in a graphical sense, the domain is the very left to the very right, right? So in general, for exponentials, the domain is the very left. Is a -infinity to infinity, the very left to the very right, right? Looking at this graph, no matter how far left you go, no matter what x you choose going to the left, you can find the corresponding y. Also, no matter how far to the right you go, whatever x you choose, you can find the corresponding y. You might be tempted to say, oh, there's a vertical asymptote at like x equals like 3 or 4 or something like that. But exponentials do not have a vertical asymptote. They have a horizontal, but not a vertical, right? So that horizontal asymptote, even though it looks like the graph is on that line, it actually is not. If you were to zoom in like Ant-Man, like zoom in like infinitesimally small, you're always going to find space between our graph and this horizontal asymptote, right? So The whole point of the horizontal asymptote is that we get we get infinitesimally close to it, but we actually never touch it. So you would have, and that's like a concept. You know, we struggle with concepts of infinity as humans, but we can get a sense of infinity, right? So that's what a lot of this is about. What is the domain? So the domain is very left to the very right. In this case, it's going to be all reals, right? So we're going to type that as negative infinity, positive infinity, and beyond, all right? Okay, and then the range, right? So now we've kind of already discussed that this has a horizontal asymptote. So the range is going to be the very bottom to the very top, right? So we said that this graph gets really close to y equals -5, but it actually never reaches that -5. So the very bottom is -5, and it goes up to positive infinity. Infinity always gets parentheses for this context. And then again, because the -5 is a horizontal asymptote, we actually never reach it. So that means the proper symbol is parentheses. Okay. Hopefully this is okay for you guys. All right. Less than 10 minutes. I don't want to keep you right at about 10 minutes. Okay, let's keep going. Next question. Let me see how many more. Yeah, we got a couple more. We should be able to get to the end. In 2003, the median price of a house in the city was $130,000. Assuming a rate of increase of 8% per year, what can we expect the price of such a house to be in 2012? So with this one, I think we used compound interest formula where the interest was applied annually, right? Because it said per year. And there was nothing that said otherwise, right? So we're going to use the compound interest formula with the interest being applied annually or once per year, right? So compound interest is A equals P times 1 plus R over N to the power of NT, N times T. All right, let's go back. Okay, let's see. What can we expect the price of a house to be in 2012? So in other words, we're trying to find the future amount, right? So we're trying to solve for A. Now the starting price was 130,000. So let's replace this with 130, 1, 2, 3. The rate of growth was 8% per year. We're going to do 0.08. If it's per year, we're going to, there's nothing. So we're going to say the interest is applied once in a year. And this is going to be a 1. And the number of years, if we're going from 2003, so if we were going to 2003 to 2013, that would be 10. But that's one too many. So we're going to do 9 years. It's a total of 9 years, right? So this is what we're going to put in our calculator. 130, 1, 2, 3, parentheses, 1 plus 0.08 divided by 1 to the power of 1 times 9. And again, I'm just putting those ones in there just in case I got to do something similar in like a question or two. Okay. Do not round until the final answer, then round to the nearest dollar, right? So the nearest dollar is 71. Okay. So then we get 25, 98, 71. 25, 90, 98, 71. Okay. Let's see how to do. Okay. Let's go to the next one. All right. So then with this one, we got like 2 more. We'll probably just go ahead and finish these 2 more, and I'll kind of hang around if people have questions or anything for a little bit, and then we'll call it a day. It says in 1627, an explorer convinced a group of indigenous people to sell him an island for $26. If the indigenous people have put that $26 into a bank account paying 8%, how much would the investment be worth in the year 2003 if the interest were compounded quarterly or continuously? Okay. Wish I had the little bar. Okay. Let me just take a copy. I'm going to take notes. I'm going to go from here. We can go to here. Okay. We can put it here. Okay, I know it might be, text might be a little bit small, but I think we can follow along. So for part A, if we're applying the interest quarterly, that means we are doing, so for part A, we're doing we're doing compound interest there. So that's going to be, the future amount is going to be equal to P times 1 plus R over N to the power of NT, all right? So we want the future amount after, let me see. If we're going from 1627 to 2003, so going from 1627, okay? This turns into a 1, this is going to become a 9, this becomes a 9, and this is 13. So what is that? 6, 7, 3, 376 years. So we're finding the amount after 376 years. We started with $25. Was it 25? Nope, it was 26. 1 plus the rate, 8% as a decimal is 0.08. If it's compounded quarterly, that means the interest is applied 4 times in a year. I'll give myself just a little bit of space. N is 4, and the number of years is 376 years. Okay. So 26 parentheses, 1 plus 0.4 times 376. Okay, closing off the exponent, and we get this, right? So we get, now I'm going to write 2, 2, 3, 6, 8, 2, 3, 3. Now we have 10 to the 14, right? 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Let me see. That's 1,000, million, billion, trillion. $223 trillion, 682 billion, 330 million, approximately. I mean, it could be the case. Okay, let's go with B. If it's continuously, so that's PERT. Whenever we're doing continuous compound interest, A of T is going to be equal to P e to the RT, PERT, right? So then we want the amount after 376 years. So the principal was 26, e to the power of the rate, which is what, 8%? Times 376. So if we say 26 e 0.08 times 376 times 14. Okay, let's do this. Approximately. All right, 300 989 5125. I think it's 14, right? So if we go 1, 2, 3, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. Let me see. 23, 68, 233, and they got 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. All right. And so for this one, let me see this, 1,000, million, billion, trillion. 1,000, million, billion, trillion. 300,989,512,500,000. Okay, so let's submit these and see how do we do. I'm gonna box these so they jump off the page. Make them pop so they're easy to find. Copy, come on, copy. Nope, undo. Copy. All right, so then we're gonna go here. Not that one, there it is, this one. Okay, so for part A, we got 223. Looks like a C, right? That's the closest one. Because again, we're limited by the capability of the calculator. So that's why we didn't get that. Okay, let's go with that result. And then for part B, 300, we got B, right? 989,512. Okay, I'm gonna go with B. Okay, let me see the time. Oh, oh, that was the last one, right? Right in the nick of time. Okay, that's exactly about the time that I wanted to stop. You guys have any burning questions, comments, or concerns before we go our separate ways? With all of these, so important pieces of information. Our exam 1 will be available starting next Wednesday. You can, for 7 days, you're gonna earn up to 100%. You get unlimited attempts at it for 7 days. After that 7th day, so when we start class on that Wednesday, the following Wednesday, that's when it's due. And you can still work on it past that time for a 10% late penalty. Also, so like our sessions, I've been pretty successful at live streaming them to our YouTube channel. So just check out my YouTube. Go ahead and like, share, and subscribe to my YouTube and turn on your notifications. It's a shameless plug, but we are using it. That's my main way of communicating with you all. And so, the recordings are there. I think every session is there. And it's one playlist. Basically, what I'm doing is dumping all of my sessions for my 3 classes. There's only 2 separate, like one's calculus and the other 2 are college algebra. But I'm putting all of my recordings into one playlist for the semester. So that's available. And then also anything that you see me writing. So like you have the blank notes before I go through them. And then you have the handwritten notes, like all the stuff you saw me writing. I'm loading it into our box folder. And so the Zoom link, the box link, access to the homework, and access to my YouTube are all right there on our Blackboard page. Okay, gentlemen? If there aren't any burning questions, we're going to end the session here. Enjoy your weekend. And from one beautiful mind to another, enjoy your weekend. Take care, guys. I'll see you next time.
I have a question.
Are you okay with it being on the stream? Let me stop.
Yeah, it has no real relevance to it. It's just about attendance.
Okay, go ahead.
I was just gonna ask. I was paying attention to the math work and stuff like that, but how is attendance usually taken? Like, do you take it in the beginning of class, or like how does it work?
Yeah, I've been taking it. So I take attendance as I let you all in, like as I let you into my Zoom session. So that's
okay. Because I had gotten an email saying that I didn't attend one of the classes, and I've been here every single class. So that's why I was wondering about it.
You heard me? When'd you get that email?
Let me go back to my. Trying to find it. Sorry about my neighbors are loud. I can email it to you once I find it.
Well, I was gonna say, because if this is the end of week 3, I want to say like it was either the end of week 1 or the end of week 2. I may have missed one of you guys sessions.
Yeah, I think it was the 18th. I want to say it was the 18th.
It should be okay. I mean, I know that you're here. Okay. If there's any trouble, we'll just make sure to keep you in there. Who am I chatting with?
Del or Delvon McLean Smith.
Smith. Yeah. And then
Yeah.
the best part, get into like the waiting room like early. Because
okay.
like the more likely to like miss those for some strange reason. I think like one time it crashed. I think I gave everybody, it's just stuff. So just, just try to get here
Yes,
early,
okay.
get your, you get to go. So
Okay,
be
thank
fine.
you.
Yep.
All right.
Okay. Any
Have a
other
nice
questions
weekend.
as well? Enjoy your weekend. All right, gentlemen, we're going to end the session here again from one beautiful mind to another. Take care. See you guys.